Our purpose at EY of building a better working world is clear. As a global organisation with a commitment to sustainability, we have the power to be stewards of change. So we're making sure our actions match our words. And we're really delighted to collaborate with Microsoft to launch the Better Working World Data Challenge.
Hello everyone and welcome to the 2021 Better Working World Data Challenge Award Show. Welcome to all of the participants, all of the finalists, all of the judges and everyone from EY, Microsoft and NASA who I know are joining us. For those of you who don't know me, my name is Professor Hannah Fry and I am delighted to be here to host the show. Not least because I get the great job of being able to talk to the winners and the incredibly smart judges a little bit later on. Now this challenge is a great example of using technology for good. And I'm sure that we have all heard of the ways that people are now trying to use technology to attempt to solve some of humanity's biggest problems. Desalination, the ocean health, plastic waste. But tech for good doesn't have to be big and showy. So I want to share with you one of my favourite examples of recent years. There is a vegetable called cassava. It looks a little bit like a sweet potato. It tastes very sweet and nutty, makes some absolutely delicious chips. Now the key thing about cassava is that it can grow in quite poor soil with very little rainfall. So it's absolutely perfect for growing in sub-Saharan Africa. The only issue is that there are several diseases that can affect the crop and have a very terrible impact on the amount of food that can be harvested. You can stop these diseases from spreading, but only if you catch it early by spotting the little signs on the leaves. That's kind of a difficult problem. But then a group of researchers were like, hang on a second, actually, there is a way to do this because we've just spent 10 years getting machines to recognise pictures of cats and dogs. And then they thought, if a machine can do that, surely it can also recognise healthy cassava leaves from diseased ones. So the researchers built an app with the potential for real positive benefit. This app, you point it at a leaf and it can diagnose what's wrong with some 90% accuracy. The hope is that it can be really transformative for smallholder farmers. They are simple ideas applied carefully and expertly by people who really understand a problem that needs addressing. In Manchester, there is a brilliant physiotherapist called Louise Rogerson, and she works a lot with elderly patients, and she saw firsthand just how late their mobility issues would get diagnosed. She wondered if there was some way to create a sort of early warning system using technology and using data. And she had a brilliant idea because she noticed that if you're feeling a bit stiff or sore, you don't really move around your house as much as normal. You won't go and make yourself as many cups of tea. You won't be turning light switches on and off in all the different rooms. You'll sit in your chair where you're comfy. And that is a pattern that would appear in your electricity usage. So she created a device that fits over the electricity meter and you install it in the home of an elderly relative or a parent, say, so that if one day they have a fall, or if they start to slowly move around less, or even if they're distressed one evening and stop sleeping, it will flag it and send out an alert automatically to a loved one. And what I think is so nice about this particular system is that people who have this system installed in the homes of their loved ones, they talk about how they used to phone their mum and have to ask questions like, are you moving around okay? You know, are you sleeping okay? And now all of that is taken care of by the technology. So they are free to have much more important questions like, did you watch the football last night? And I think there's something really positive in there, that sometimes when it's done right, more technology can actually help us to be and feel just a little bit more human. And that really is what today is all about. So, on with the show. And a very big thank you to everyone around the world who joined the challenge this year to use technology in the fight against bushfires, or you might call them wildfires. Now, there is a whole complex ecosystem involved when responding to bushfires, and that makes the entire thing not impossible, but really, really difficult. So that is why EY, Microsoft, NASA, Geoscience Australia, Swinburne University and the Country Fire Authority in Australia set up this challenge to get really bright data and tech minds on the case of how to use AI for good. And that is what makes this challenge really special, the sheer number of partners who came together to commit to finding a way to use AI to help fight bushfires, as well as the unbelievable datasets and the nearly 9,000 people who joined to help make it happen, of course. Now, I should say too that the IP from the winning models will be provided free of charge, not just to firefighting authorities around the world, but also to government agencies and other organisations. And that is how you make a challenge like this actually mean something and have a real impact. And I know that for EY and a lot of their partners, this 2021 challenge is just the start of the journey. So here we are with the 12 global finalists. So congratulations to all of you for making it this far. Now, I wasn't joking when I said that this challenge was complex and difficult, because otherwise somebody would have done this already, right? So to be a global finalist is genuinely amazing, as are all of the models that you have come up with. I looked at all of your submissions and I was incredibly impressed with your innovation and creativity, just how different your different approaches were. And you should all be very proud of the difference that you're making in the fight against bushfires and climate change. Now, this video explains a bit more about the challenge.
Technology and data are changing everything, from how we work and create value to how we live and interact as a society. So we asked students and young professionals around the world to use data and technology to change the way the world works for the better.
It's always exciting to get students involved because they bring fresh thinking. They approach problems in a very different way. And through my involvement in these challenges over the years, I've seen some very unique ways to problem solving.
I love the idea of a student competition. I love the idea of government partnering with industry to do this. And that's why I found it unique and I wanted to be part of it.
Wildfires are a global problem, increasing in frequency and severity. And as global temperatures continue to rise, our changing climate will inevitably lead to more severe and intense wildfires. So the ability to detect and manage fire as it spreads in real time is invaluable, but it's difficult. Fire edges expand rapidly over time, and tracking fire behavior from space is complex. So we asked thousands of students and young professionals around the world to develop an automated fire edge detection and prediction model using airborne and satellite imagery.
Now students can really bring change by having the power of their mind and working with cutting-edge technologies, data science, machine learning, and to bring this change.
The models from the challenge will help save lives, property, and wildlife by allowing fire authorities to warn the right people at the right time and use finite resources more effectively.
My only expectation walking into this is I'm going to walk out of it seeing something that somebody's done that I never would have thought of. That's the key.
We stumble into all kinds of interesting problems when it comes to utilizing this data and producing products. And who knows, there might be something really clever that comes out of that we use elsewhere, in the world. That's one of my hopes.
Over 8,700 participants from more than 115 countries and 1,100 universities. And now our global finalists are vying for a total of $24,000 in prize money. Welcome to the 2021 Better Working World Data Challenge Awards show. Don't just predict the future, build a better one.
Something really clever that we use elsewhere in the world. Well, I really hope that we do too. So, okay, let's take a closer look at the challenge and what the finalists were asked to do. There were 2 challenges, each with a first and second prize. Challenge 1 was the fire mapping challenge, which asked people to develop a model for automated fire mapping using infrared line scan images. Now, this one has a top prize of $6,000 with $3,000 for second place. Challenge 2 was the fire behaviour challenge, and this one was a bit more complex. People had to take the solution they developed for Challenge 1 and then forecast the missing fire map in a sequence of airborne and satellite images. This one has a top prize of $10,000 with $5,000 for the runner-up. The winning models from this challenge will help fire authorities answer really critical questions, like who they need to warn and what locations need to be evacuated, ultimately helping to save lives, property and wildlife. So there's a lot at stake here. And now here is a message from Carmine DeCibio, EY's Global Chairman and CEO.
Hello, this is a special message for 2021 Better Working World Data Challenge Awards Final. A big congratulations to all our finalists. We had overall 8,600 participants from 115 countries and 1,100 universities. Also a big thank you to all the judges. At EY, we're creating long-term value by having a positive impact on our communities and planet. We are so proud to be carbon neutral globally for fiscal year 20, and we have a pledge to be carbon negative for fiscal year 2021, and each year going up to 2025, where we will also be net zero. But none of us can solve these challenges on environmental sustainability on our own. We are working with our clients and organizations to support carbon reduction and inspire action. But also, we're working with people like you who are using your skills and knowledge to not just help predict the future, but to build a better one. Thank you all for everything that you're doing to build a better working world, and best of luck to our finalists.
Carmine is absolutely right about not being able to solve sustainability issues alone. And the truth of that shows in the almost 9,000 people who signed up for this challenge. So let's take a look at how the top 12 teams were selected. First, they had to perform well in one of the challenges, the fire mapping or the fire behaviour. That gave us the global semi-finalists. And these teams then had to submit their workings and their methodology, all of which were scored by an evaluation panel. And then the top 6 teams for each challenge are the global finalists that you have seen here. Then the incredibly smart judges took over, scoring the finalists on their critical thinking, their methodology and their communication. So let me introduce those judges. We have Alan Duffy, Alan Slipchevich, Brian Killow, Dan Morris, David Schmoyes, Hafsa Sharif Dar and Olivia Sackett. Very impressive judging panel there, and we're going to be hearing from them later as I'll give them a very gentle grilling about why the winners were chosen. I hope they're on their toes. So, okay, without further ado, let's see who are the finalists for Challenge 1.
The most exciting thing was that this could have actual real impact somewhere in the world.
We decided to take on this challenge because we wanted to learn new skills and also to discover a real-life application of AI.
When I saw the advertisement for this competition that you were prepared, I say to myself that I have to park with it.
To get a better prediction, we learned knowledge about bushfire features and some other new algorithms.
I was thrilled when I saw it. I felt I could do something to really impact the world.
Hello, my name is Tom.
My name is Dominic Bank.
Hello, I'm Catherine.
I am Eric.
And I'm from Czech Republic.
Hello, I'm Zephyr, and I'm a a computer engineering student.
Hello everyone, my name is Chen Yi. I'm from China.
So hi everyone, I'm Hubert and I come from Poland. I live in the city of Katowice.
My name is Clément. I'm from France, in the south of Paris.
My name is Ricky. I'm a plant math student in my university.
So my name is Kevin. I'm also from Paris.
So my name is Cindy. I'm from Ghana. And Franklin introduced the Better World Data Challenge to me. And I thought it was really interesting because of the increase in global warming.
This was like the first real world task I was able to like participate in it.
The biggest point of our solution were first that we annotated some of the fires that were mislabeled or forgotten.
First, our team adopted an improved UNITE model. Compared with the traditional image segmentation method, UNITE can automatically extract and combine features without manual design.
And through many attempts, we gradually got familiar with the advantages and some drawbacks of some models. And we also had a better understanding about how to appropriately utilize those models.
I think the biggest difference is that we used k-means and polygon simulation.
I think EY should do more challenges like this. First, because it brings awareness to young people who maybe are not aware of what happens in the other part of the world, but are still very important.
Instead of just having a contracting network, which had pooling layers in between, we complemented it with an upsampling operator, and the upsampling operator also had quite a number of features within it.
I learned how to deal with the interface data, and we built a UNITE model and how to present the output image according to the actual situation.
My solution is quite simple. It's based only on satellite image only want to mark the fire and on historical photos that covering the area.
I think the biggest difference would probably be the efficiency and the scalability of my solution, which has very short inference time, and there's more potential to improve it.
Another advantage is that we can apply my solution anywhere in the world.
By comparing the drawn polygon for testing set with our clustering model, we finally achieved more than 0.8 prediction score for both methods, which is a very excellent result, I think.
Our final solution is based on two deep learning models that we train on Azure, and also a Google Collaboratory to produce the final results.
Yes, I think the most important thing is the spirit of cooperation and perseverance.
Bushfires happen everywhere around the world, and they are becoming more and more frequent. I think it's a problem that should be important to everyone, as bushfires are a danger to many animal species, but as well as humans.
I think AI makes the working model of human labor tend to be simple, efficient, and tend to be free.
Though when we started, we didn't have all the answers to the questions, but then with perseverance and with also persistence, and most importantly, believing in ourselves, we're able to come up with solutions to the problems along the way.
Even though it is not that affecting me every day, but it's one of those things that could affect the real world issues and make the world a little better place.
So, just in case you missed it, the finalists for Challenge 1 are Team 10:30 p.m. from mainland China, Team Aftermath from mainland China, Team Sindelin from Ghana, Dominik Benk from the Czech Republic, Team Firefighters Scientists from France, and Hubert Cherevitz from Poland. Now, I have to say to all of you, I've seen your videos and the standard of your submissions was absolutely incredible. You should all be very proud. But we have to have a winner and a runner-up. And the runner-up for Challenge 1 is Team 10:30 p.m. from mainland China. And they join me here. Congratulations to both of you. You must be very happy.
Yes.
Yes.
Did you find the challenge difficult, Chenyi? Was it a real technical challenge for you?
I think in my opinion, it was very difficult to find a suitable model. Our team spent a long time searching for related information on the internet and the literature. After comparing so much models, we decided to use the adjusted UNet model. This is also the core part of our solution.
And Dong-Yu, were you surprised that the technique that you chose worked quite so well?
Yes, very surprised. When we uploaded the solution for the first time and saw that we get the first place, it was hard for the 3 members of our team to believe. In my opinion, this has a lot to do with our choice of a suitable model for the fair images problem. I think it's a surprise to get such a good results in the end, but it's also worth our efforts.
I would say so too. Very impressive stuff. And Chenyi, what does it mean to be chosen by the judges as one of the very best submissions?
I think it was very happy with the result. It's unexpected for us to get the second place among thousands of competition. In the beginning, we just want to learn some related knowledge, but we didn't expect that we could win a surprise in this competition. So it was an extra game for us.
Well, congratulations again to both of you. Really remarkable achievement. And now let's hear from Judge Hafsa Sharif Dar from the University of Gujarat and Alan Duffy from Swinburne University about why Team 10:30 p.m. were worthy runners-up. Hello to both of you, Hafsa and Alan. Thank you very much for joining me. Alan, if I come to you first, what was it that you liked about this submission? Why was it a worthy runner-up?
I really enjoyed the way the team, Chenyi, Dong, and the self-titled T-Dog approached the problem. They made clear what the limitations of the data, lack of labels, its scale, and then also what the end user needs were. And they identified that their solution met those needs and indeed went further to offer even improvements. That's the way you build trust in data science, by making clear to the end user exactly how you've solved their problems rather than just say it's a black box, trust me. And they've shown great maturity with that approach and a wonderful presentation.
Absolutely. And Hafsa, if I come to you, I imagine there was quite a range of approaches across the submissions to this challenge. What made for a good approach, do you think?
I think they have used the architecture in the model in its improved form. They had to deal with lots of challenges, and then they combined that solution and proposed the solution of those problems. So I think the use of that improved UNet model along with all the data pre-processing and data cleaning, they had to face other challenges related to images, like large sizes of images and cleaning of images from the satellite were normally not clean. And then there were identification of invalid regions. So I think their approach in that sense was also appreciable.
And Alan, just more generally, if you could, were you impressed with the standard of submissions for this challenge?
Oh, hugely. I mean, these entries were so far beyond what I could do. And this was in a number of instances from people who had no prior experience in data science. It just speaks to their intensity and maturity of approach, how much effort they really took to create solutions that could deliver a better world. And they saw that societal benefit and really ran with it. And I think it's to their credit that it was such a tough time making the final judging call, and I'm just in honor of all of them.
I quite agree. Thank you to both of you very much indeed. And now, the winner for Challenge 1 is Team Firefighter Scientists from France, and here they are. They're joining me here. Thank you so much to all of you. Congratulations. I have to tell you, not many people get to say this, guys, but I think you genuinely have helped to build a better world. I think your work is going to be used to make a real difference, and I think your solution genuinely will go on to save lives. So thank you so much for all your hard work, and congratulations on your victory. I have a few questions for you, if that's okay. Eric, tell me a little bit, how did you come up with the idea for how to solve these images?
Yes. First, we tried many state-of-the-art models, but they were too complex for the data we had. So we turned into a simpler model, which is called UNet, and it is using less data. That's how it is.
Use a lot less data. But you didn't just use one model though, right? I mean, you use several models together and sort of connected them up. Tell me, why did you choose to do that, Clément?
So we decided to do that because we did some research about machine learning competition in general, and we found that many winning models actually combine multiple neural network, multiple algorithms. So in addition to the UNet, we also used a model called CGAN, which we found out after managing to get a good score with the UNet. So looking for scientific paper, we found this model that helped reduce the noise in the image, and that gave us an even better result.
You're underplaying it there, but it really was a very good result. Kevin, just tell us, how well did your model perform?
So at the beginning, our model yielded a pretty good score compared to our previous approaches. So the masks that were produced by our model visually stick to what humans would do to annotate the fire on the images.
And are you surprised to have won, Eric? How about you? Has this come as a bit of a surprise to you?
Oh, it's a really big surprise because we were ranked 5th at the final leaderboard, and they did less submissions too, meaning that maybe we had something very performant to submit. So we, at our 5th place with a lot of 40 submissions, we definitely are surprised.
It's not just about performance though, right? It's about the ideas and connecting up dots from different areas. I think it's the originality of your work. Tell me a bit about your experience up until this point, Clément. How much coding had you done before?
So the three of us are actually from the same engineering school in France. And this is a school that is specialized in computer science and mathematics. So we did quite a lot of projects related to computer science. And the three of us also started doing data science project and take data science class about 2 years ago.
So only 2 years, incredible. And Kevin, any big ambitions for what to work on next?
Personally, I would like to continue my journey as a data scientist, and I want to really have to work on a meaningful project that can have a real impact on our world, like the data change that we just won.
Well, you certainly made a good start in that regard. Congratulations, huge congratulations to all three of you. And here to tell us why Team Firefighters Scientists were worthy winners is Judge Brian Killow from NASA Langley Research Centre. I'm delighted to have you here, Brian. Tell us, what was it that you particularly liked about this winning entry?
I thought their solution was quite innovative. One of the things that struck me was that they took a problem that had been solved for biomedical engineering called image segmentation, looking at biomedical images, and they adapted that to this problem for mapping fire boundaries. And I found that approach was very interesting and innovative.
And effective too, right?
Indeed, yes. Their solution had results that were more than 90% effective. So they took data that they looked at fires and they tested against that fire to create a model. And then they applied that model to other scenes with unknown fire boundaries. And they were able to match the correct boundaries at well above 90%. And that's outstanding. And that's what we normally try to achieve when doing machine learning.
And you didn't make this challenge particularly easy for them, did you? I mean, I know that you didn't give them too many images to work from, but also there were some tricky things within the images themselves, weren't there?
Yes, the data that they had to use was what I would call scarce. They didn't have a lot of images to use. They also had an imbalance between the number of fires and the number of non-fire within those images. So when you're faced with a limited set of data, it provides a challenge for doing the machine learning models and also achieving a high level of accuracy. If they had a much larger set of data, they could have gotten even better accuracy results.
And what was the range of submissions like? How much did this one differ from the others that were entered?
There were a lot of similarities between these submissions in a sense that they all used some form of a model or image segmentation. The key difference between those that really excelled and the better solutions were those that took into account several different techniques for thresholding. So though there were a lot of different ideas, the ones that excelled looked at all of the possible ways to do this problem and found an optimal solution.
And a particularly impressive solution in this case. Brian, thank you very much indeed. And now to tell us just how important the winning models will be in helping firefighters on the front line is one of the judges, Alan Slipchevich, Executive Director, Bushfire Management and Deputy Chief Officer at the Country Fire Authority in Australia.
All the main drivers of fire behavior have a lot of uncertainty around them. Sometimes we don't know exactly where the fire is and what it's doing. We have a lot of uncertainties around our fuel types, their structure, composition of fuels. Fire behavioral models have inherited limitations in what they can predict or cannot predict. So that all makes uncertainty about predicting how the fires will behave and what they will impact on and at what time they will make an impact on communities and the values in the landscape. A mapping officer is the person that creates the maps for the fires. The mapping officer is a part of the incident management teams. It can take any time between half an hour and number of hours to create the most accurate maps because they have to look the data from different sources and then make sense, map those ones, print them and deliver them to either crews on the ground, to incident management teams that make decisions, or out to the public so the public are aware of what the fires are doing. There is always a lot of uncertainty in managing fires. Any tool that will provide us with more information on what might happen next or what impact our decisions will have on managing those fires will make our communities safer. It will also help us to save other things that we value in the landscape. So an automated system will allow our mapping officers to spend more time in interpreting the active fire edge so they can provide more accurate information to incident management teams. At the peak of Black Summer, bushfires were spreading at the rate of about 10,000 hectares an hour. So any efficiency that we can gain in mapping officers and fire behavior analysts to provide quicker information to decision makers will reduce the impact on the communities and firefighters.
Microsoft has been investing in technology for good since quite a long time. One of our big focus areas is AI, because we all know that artificial intelligence has the potential for great good, but also the potential for negative side effects. And so we believe that the more examples we can show that AI can and is being used for great things, it is very clear that the public will get more trust and confidence that the people that are inventing and innovating in AI will do great things for human beings with that AI technology.
You know, this challenge really aligns so well to our purpose of building a better working world. Our people are passionate about that purpose and about our commitment to the environment and climate change. So this ticks all those boxes. Yeah, this challenge is one great example of many different ways we're trying to use technology and data for good to make a difference, to have an impact on society, whether that's closing the digital divide in the Americas for populations that might be disadvantaged in their access to technology, or what we're trying to do to drive diversity into technology workforce more broadly as a global initiative, or indeed how we're helping clients really with their own sustainability agendas, whether it's renewable energy or lowering their carbon footprint. So a number of different ways that we're trying to really have an impact.
We actually have a all-up initiative called AI for Good, and we put two things together. One is an investment fund of, I think, $1 billion that is being paid out based on a grant system. So you can apply for a grant, and if we feel that it works, we effectively will go and support your cause. So my personal view on AI for good, or technology for good to be broader, is really to have all these wonderful corporations out there, all these wonderful people, to use their ingenuity, their perspective, and their areas of concern. What are you worried about? What are you thinking where technology can help? Come together, bring them to EY and Microsoft, and challenge yourself and challenge us to do the right thing with this great technology.
So I don't know if you'd call it a vision or a hope, but I really do hope that we continue to put humans at the center in how we think about the impact that technology and data solutions can have beyond our own agenda and in terms of society, in terms of the environment. And when we're able to team with our ecosystem partners such as Microsoft, the impact that we can have is amazing. And then you bring the energy of the thousands of people that participated in a challenge like this from around the world. It's truly inspirational to see that.
Some really exciting initiatives there from both EY and Microsoft. The future is closer than we think, and it is great to see big global companies stepping up and using tech for good to help make sure it's a better one, which is what this challenge is all about. So now it's time to turn our attention to Challenge 2. Let's take a look at the finalists.
The thing about fires is that it knows no boundaries, and it can be quite random at times, because you feel like we've all seen fire sometimes, you set fire here and there, you see the embers just fly in any direction.
We are living in cities and towns, but we are connected to the nature. That's why I think we have to save our nature.
The Australia bushfires were just really widespread, and then I saw the videos of the habitats, the natural habitats being destroyed.
Okay, so I'm Christian Tomazi, and I am a PhD student in Hungary, Budapest.
My name is Franklin Ejik. I'm from Ghana.
My name is Taufik Usada. You can call me Taufik.
My name is Suzy. I am a student at the Budapest University of Technology.
Hi, I'm Yuhao. from Nanyang Technological University of Singapore.
You can call me Johan.
Hi, I'm Junwei, and I'm from National University of Singapore.
And I'm from Indonesia. I'm living in Jakarta.
Hi, I'm Nishan from National University of Singapore.
Hi everyone, I'm Skylar from Singapore. I'm currently studying at Nanyang Technological University.
My name is István Kérészi. I have a background in Hungary, so I was born in Hungary, but I grew up basically in Florida, and right now I'm doing my PhD in physics at the University of Florida.
I believe my solution is the best because my solution is simple. I only use some image processing techniques to do some image thresholding and calculate the speed of fire.
Instead of using just a single discriminator, we use a multi-scale discriminator which has 3 different discriminators. So the first discriminator just length on the raw images, the second one length on the raw images scaled down to a factor of 2, the third one length on the raw images scaled down to a factor of 4.
I think the unique point of my approach is that I using something called field penology.
I think the main differentiator in ours is that it's simple, robust, and flexible.
So I just made my model have it spread in all directions, but how fast it spreads is accounted for based on those information we have.
And what I mean by field penology is more like basically plants and trees and bushes around in the forest that help the fire to keep burning and evolve in that area.
We actually use the NumPy arrays itself to calculate like the speed of the fire spread.
Quite easy to understand how it works, even for not machine learning or AI professionals.
To sort of mimic the fire spread, we used the CV2 dilation function.
In real life, in the field, people might not have access to supercomputers. It should be something that firefighters in the field can apply easily, minimum computational power, and that's something that can be understood.
So I wanted my solution to be a bit faster because every second counts when you're fighting fire. You know, you're literally fighting fire.
I was really inspired. The fact that a project I was going to work on was going to be used in some other parts of the world to solve real problems really inspired me to go on to learn more about it.
Or maybe we can use it to kind of give the model for the early warning system. So the people who live around the wildfire can be noticed before the fire gets to them.
Very motivated to pursue more challenges in the future because winning this would really show us that we can have such a big impact on the world.
That made us really have the passion to tackle this problem, and I think not only us, the other participants have done a great job in contributing to solving this problem.
So this idea of making AI accessible and making science accessible to a lot of people is something that I find amazing.
I find the enjoyable thing is that the results at the end, because we put in so many numbers and then we get something that helps us make sense of what's actually going on.
Start dealing with AI 8 months ago, and I think this challenge was a very big opportunity for me to try out my knowledge.
They've really opened, I would say, a window for people out there who have solutions, but then without the platform to give the solutions to the world.
So again, just in case you missed it, the finalists for Challenge 2 are Team A. from Singapore, Team FNN from Hungary and the United States, Franklin Koomson AJ from Ghana, Skylar Lim from Singapore, Taufik Husada Daryanto from Indonesia, and Tia Johan Setiawan from Indonesia. I have had the pleasure of looking through all of your reports, and really they are astounding. All of you have achieved a great deal already just making it into the final. But we can only have one winner and one runner-up. And the runner-up for Challenge 2 is Franklin Coomson, AJ from Ghana. Franklin, congratulations. You must be very proud of yourself.
Yeah, thank you very much, Hannah. I must say, I'm a bit surprised I didn't win though, but then I'm so proud. Yeah.
Now, I noticed in your report there are an incredible number of techniques that you had to master really here. I mean, I noticed you were using ArcGIS, you were using Python. Did you have experience of this stuff beforehand?
Yes, please, with some of them and with some to a little bit of experience, specifically with ArcGIS. I had a bit of experience with ArcGIS, but with the conditional gun, I had I would say 10% experience. Yeah.
Did you find it challenging then, applying it to this new set of data?
Yeah, I must say this data was very challenging. It had a lot of problems, and I termed it noise in my accept. The noise had to do with the image itself didn't come with a full background. It came with backgrounds, black backgrounds at the sections, and there was a demarcation on the real image taken by the satellite. And also some of the images had black areas covering the line scan areas, and it was a bit challenging getting the model to learn to be able to predict the next frame. So I had to bring out solutions to curb them, and I would say I'm surprised that it worked, and I'm glad I worked too. Yeah.
I mean, it worked very well indeed. How many hours do you think that you spent getting this all together?
I would say for the challenge 2 alone, I spent roughly like 4 hours a day. That's after like 30 days into the challenge. Yeah.
My goodness me. Well, your hard work paid off, and all of us are very, very impressed with what you managed to achieve. So congratulations. Well, here to tell us why Franklin was a worthy runner-up are judges David Schmoyes from Cornell University and Dan Morris from Microsoft AI for Earth. Hello, Dan and David. Hello to both of you. Tell us a little bit about this challenge. It wasn't a particularly easy one, was it, Dan?
Nothing having to do with geospatial imagery is ever easy. And also, even as far as computer vision goes, most of your kind of stock out-of-the-box approaches that people use are about image classification or even object detection. These more complicated semantic segmentation tasks definitely require a lot more creativity.
And what was it about Franklin's submission that impressed you in particular, David?
Well, it was just technically a very strong contribution. That the extent to which he used sort of a multi-scale discriminators, that he incorporated really state-of-the-art technology in doing this, pushed him to really be, and of course the element beyond just the geospatial is in this second challenge is the time series element, which he was very creative in terms of how he was handling.
And in terms of these techniques that he put together, Dan, do you think that his submission could be useful out in the real world?
At the end of the day, the quantitative score of this submission speaks for itself. It did very well on the test data, and that's the best that we can ask for in terms of probability of generalizing out to the real world.
And speaking more generally, David, about the submissions that came in, I mean, it required quite a lot of technical skill to answer this challenge. Were you expecting to see submissions at this sort of level?
I certainly was hoping that there would be. I mean, that the extent to which the technology has excited the student population in the world, and a challenge such as this to sort of reach out and leverage all the talent that's out there taking classes around the world. This is really showing a sign of how much the technology is getting infused into our educational platforms.
And how much talent is out there, I suppose. Thank you very much, David and Dan. Congratulations again to Franklin Coomson, AJ there. But we have our winner for Challenge 2. And that winner is... It's Tia Johan Setiawan from Indonesia. Johan, congratulations. Amazing accomplishment this. I mean, you're such an incredibly talented man. You beat hundreds of people really here to win the challenge. Are you pleased? Are you proud with what you've achieved?
Oh my God, thank you so much. I'm really surprised that I win this challenge. And I thanks for UI team for this competition. Thank you.
Well, your work was really very remarkable, Johan, and particularly I noticed you wrote in your report that you had very little experience of coding up until even a year ago. How much did you have to learn to really accomplish this task?
Yeah, I just have experience in programming when I back to in study in engineering, but in data science domain itself, I just learned last year. And this one is my real first project, I think, for data science.
And in particular, in your project, you combined different images. You had satellite images, but also scanning images. Why was that important to you to combine those together?
Yeah, in my approach that I try to solve this challenge, of course, I try to solve the challenge one first. And when I try the first one, I use only the infrared actually, and my result is not so good. So when I pass the challenge one and I start the challenge two, I think that I need to find some factor that can help me to find a better solution that provide in the data.
But you tried lots of different things. I mean, as well as combining different images, trying one and then trying the other, you also tried out different models, didn't you? There was the random forest, but also linear models.
Yeah. When I make the training for the model, it's actually just training and find the better model for my approach. But I think the important part is still the understanding the cases and the data itself and the approach that I use for analyze the challenge and make the solution.
And what did you find particularly challenging in achieving your goal here?
Yeah, as I mentioned that one the challenging part of this approach is that we need to understand the problem, which is predict the wildfire behavior, and also the data that we have. We given infrared data, but also some satellites data. So I think we can, when we understand it, we can take insight and make a better approach for find the solution.
Amazing. And what does it mean to you to have won, Johan?
Yeah, it's really grateful for me to win this challenge, and I think that this challenge is give me opportunity to learn by giving me many guidance and many resources to trigger me to find a way to learn about data science and find the solution for the one of the real world problem, which is Australian wildfire.
Well, you are really a very exceptionally talented data scientist, a really exceptional submission. Congratulations again, Johan. Really amazing work. And now we also have our judges here, Olivia Sackett from EY Oceania and Alan Slipchevich from Country Fire Authority, Victoria, Australia, about why Johan was such a worthy winner. Hello to you, Alan and Olivia. Thank you very much for being here. I recognise it must be getting quite late by now in Australia. Olivia, tell us what really made this submission stand out for you?
I really love the fact that Johan was able to use satellite imagery in addition to line scan imagery collected from aircraft. There weren't many people who submitted to the challenge that were able to do that, so that really made him stand out.
Fantastic. And Alan, what kind of a difference could this sort of a model make?
It can make a massive difference, really, because the quicker we predict fires, the quicker we can adjust our strategies in battling those fires, and also we can provide advice to our communities to make them safe.
Olivia, tell us a little bit about Johan's focus on fuel in his model.
Yes, I thought it was pretty creative. Johan was able to use something called the NDVI, which is this vegetation index that you can create from infrared data collected from satellites. And he basically created a proxy for the amount of fuel available for the fire. And that was a really key part of his methodology.
And Alan, that focus on fuel as opposed to looking at weather or maybe topology of the landscape, is that a useful simplification to make?
I think it's a good first step, so it's a step in the right direction. But if you add to it, if you add to the model the weather information and also topology, the model will improve quite significantly. So the model is already working really well. If we add those two components, it will work much better.
I noticed when I was reading the report that Johan tried lots of very complicated techniques, random forests, I mean, all of these quite high-level techniques. And in the end, actually, it was the simplest model that worked. Olivia, do you think that's a bit of a surprise?
Oh, not really. I mean, we do often find that some of the more simple models are the best. So it's really good to see a variety of different approaches tested out because, sometimes you do strike it lucky and find a complex model that works really well, the random forest that you mentioned, for example. But no, I'm not particularly surprised that it was a simple model that was the best in the end.
And Alan, I know that Johan had never analysed satellite or scanning data before. Do you think this is quite an accomplishment to manage this with so little prior experience?
Absolutely. He has done overall a really great job. And I really like how he trialed different options and then selected the best performing model to create the model. So it was really, really great work. Very impressive.
And Olivia, last word to you. Are you impressed by what he managed to achieve?
Oh, absolutely. We have people who are working for years on a topic like this, and the fact that Johan hadn't used satellite imagery before and he was able to build a model using, two different data sources and get into the top of the data challenge with hundreds of people, I think is an amazing accomplishment.
It certainly is. Well, thank you very much, Olivia and Alan. And thank you to all of the judges for being such great sports with all of my questions. And congratulations to all of the winners, the runners-up and the finalists. An incredible achievement. And now to close the event, it's Errol Gardner, EY's Global Vice Chair of Consulting. Hello, Errol, are you there?
Thanks, Hannah, and thank you for being such a great host. I would also like to thank all of our other partners and collaborators who've been critical to the success of this venture. I am excited to see the impact that the outcomes of this challenge will have on bushfires and how they are managed around the world. We hope to see significant improvement as we look to take the winning models to firefighting authorities around the world. The IP from this challenge will be provided free of charge to non-commercial organizations to help create change and to build a better working world. It's this real-world impact that really sets this challenge apart. And I'm delighted to say that we are broadening the scope of the challenge moving forward so that we'll include all the sustainable development goals, not just climate change. I think this is a really exciting development as it means future challenges could be looking to help address issues that range from a lack of education to poverty and how do we reduce inequality. Personally, I can't wait to see what's next. Thank you to everyone who's participated in this 2021 data challenge, and a huge congratulations to all of the finalists and winners. Look out for the 2022 challenge. Back to you, Hannah.
Thank you very much, Errol, and thank you to everybody who has joined us here. It has been a real treat being your host, and I hope that you will all be here again next year. Goodbye.